My name's Peter Alger. I'm one of the co-authors of AI as a Service, and with me this evening is Owen Shanahy, who's the brains of the operation. If you want to say hi, Owen.
Hi, everybody. How's it going?
So what we thought we'd do for you this evening is to walk through our cat detector workshop, which is chapters 2 and 3 in the book. And we've kind of broken this out into a 10-step workshop. So we're going to be walking through that and live deploying the system onto AWS. And I'll be doing most of the kind of deployment, and Owen's going to be watching the channel, and we're picking up on any questions so that we can cover off any issues you have as you go along. So we'll just give it another minute or two so we don't start too early. In the meantime, of course, there is a 40% discount code available, which is on screen now if you'd like to snag a copy of the book. I notice actually I might just adjust our video sizes there, Owen. Just to flick forward one slide here, we also, the code we're going to be running today and deploying is available in this repository here. That's on screen now. So feel free to go and clone that repository and work through that in your own time. For convenience, we have created a Docker container which has all the tooling set up for the workshop, so that you don't have to be messing around with your own environment setup. So hopefully that helps. You can pull that container at that repository link there. So Docker pull Pelger AI as a service. And there's also some instructions on GitHub. That's in part of the workshop. So we're going to be walking through that in any case. So I'll just leave those up for a moment if people want to check those out. And I'll start moving on now in a moment. Just once again, there is the discount code if you want it. And also we have the reference to the workshops. Okay, so
so all of that info is in the chat now, Peter, as well.
Excellent.
So
that's brilliant.
The repo, the book link, the book code, and the GitHub repo.
Super. You keep resizing on me, Owen. So it's just adjusting the sizing on the so people can see code. I'm not sure why, but we'll keep going. Okay, super. So let's get right into it then. So this is the repository on GitHub. So I'm going to be working through the instructions on here, but we'll take some time to really look at the code in more detail. So there is a file, there's a README called quicksetup.md if you're impatient and just want to get going. But otherwise, we'll take it a little bit slower and explain things in a bit more detail. So what we're going to build in this workshop is a serverless image recognition system. And we'll be touching on a number of different AWS technologies, including S3, Lambda, SQS, and of course, recognition, which is one of Amazon's AI-enabled image recognition services. The UI that we're going to ultimately deploy looks a bit like this picture here. And here, of course, we've used it to detect images of cats. For the workshop, if you want to work along with it now, or if you want to work along with it later, you're going to need Docker installed to run the convenience container. You will need an AWS account and also AWS API access keys. But we'll take you through how to configure that and get that set up now shortly. If you have those prerequisites, it usually takes a couple of hours to complete, but it's not a race. There's 10 steps, and of course we welcome and value any feedback you might have. You can reach us at fortheorem.com. You can email us at the link there. You can tweet either of us, or of course reach us on LinkedIn. Okay, so let's walk into step 1 then. So step 1 is we're just going to have a look at an overview of the system and what we're going to be building in a little more detail. So we've basically broken it up into 4 different sections. Section 1 is overview and setup tooling to make sure that everything's good to go. Section 2 is looking at the serverless framework, the underlying infrastructure that's going to support the system, and also some of the capabilities of AWS recognition. In section 3, we'll look at the asynchronous services, which form part of the system. And in section 4, we'll deploy the upper layers of the system and finish with a finished UI. That's the end goal. We've already seen that. And here's the architecture for the system. I'll just see if I can zoom out slightly on that. Nope, sorry. Let's go back now. So here's the architecture for the system. So at the top, we have a single page application that sits in the browser, and that's going to talk to an API gateway, which we're going to deploy. That API gateway is going to talk to some Lambda functions, and that's going to be a synchronous calling pattern. Those Lambda functions are going to either return data for displaying in the front end or kick off analysis jobs by posting messages into an SQS work queue. Those work queues are going to communicate either to the crawler service, and the crawler service is going to go and fetch images from a page for analysis and put them into S3 down here, or the analysis service, which is going to pick up those each of those images that's been downloaded, feed it into recognition, get back some data, and store the results from the image recognition into the S3 bucket. And then those results are going to be made available for processing on the front end through our API. So it's a fairly standard tiered web application built using serverless. And I suppose the interesting piece is really the recognition service and ultimately deploying a fully serverless web application. For this, we're going to be using the serverless framework. And don't worry, we'll walk through the serverless framework, how that works if you're new to it, so that we're not making any assumptions here. So let's crack into step 2 then, which is getting our tooling set up. So as I mentioned, we've created a Docker container for convenience. So let's just go over how we're going to work with that in building the system. So we've put a bunch of tools in that container. So Python 3.7, a Jupyter Labs server, the AWS command line interface, Node.js, and also the serverless framework. And the image below kind of shows you how we're going to be working with that. So we'll be working using the command line, and our command line will be hosted within the Docker container. That means we'll have full access to all of the tools inside the container. That is then going to serve up some notebooks, and we'll do some testing in those notebooks. And of course, we're going to use the serverless framework and the AWS CLI to deploy our application up to AWS, and we'll be able to then access that through a browser. So hopefully that's clear. So to get started, what we need to do is clone the repository. If you haven't cloned it already, go ahead. If you haven't set up Docker, you'll need to set up Docker, and then pull that container, Docker pull Pelger AI as a service. Once you've got the just alternatively, you can build that from scratch if you wish. There's a Docker file there, and I'll go through that in a second. However, it's probably going to be quicker just to pull the pre-built container. Okay, so let's.
It's going to take a while for sure. It's a good idea to pull a container. There's quite a few layers in it, so if you can pull it, that's definitely the quicker way to go.
Yeah, I think it's probably not the most efficient Docker file. I would confess to that. It could probably be made a little more efficient in terms of the layers, but definitely you're right, Owen. Pulling container is going to be a lot better. So let's flip over to some code over here. So this is actually the Docker file. So as you can see, all it's doing is installing a bunch of tooling and so on. And then what happens when you start the container is it'll run a script called start.sh. So if we look at that, what that's going to do is it is going to cd into our home directory. It's going to spin up a Python virtual environment. It's going to run a little script to check bucket names, and I'll come to the configuration for that in a moment. And then it's going to spin up our Jupyter Lab server. And we run all of that with a script called run.sh. And all that does is to run the container, exposing port 8888 to the local machine, and sleeps for a little bit to make sure everything comes up okay. And then runs a docker exec -ti workshop bin bash. So what that means is connect to the container with a bash shell. So we've just automated all of that for you. So what I'm going to do is I'm going to now in the container directory, I'm going to start the container and in a sec. Sorry, Owen.
Peter, I'm not seeing I'm not sure your terminal is coming correct through.
Oh, okay.
I'm getting
Okay.
I don't know if that's the same for everybody else, but might want to just check that, or at least
Yeah, it's coming through okay.
flip back and forth.
Yeah, how about now?
You're seeing it okay?
What are you seeing now?
I'm just refreshing, Peter, actually, to check if there's any problem on my side. So it just seemed to happen when you switched over to the terminal.
Okay.
To run those commands.
So I'm using.
I'm logging back in again.
I'm using a Mac and I'm swiping across desktops, so that might be causing the issue. In which case, I'll just switch the command window and drag it onto the desktop. So I might just do that now, just to avoid any issues. Yep. Hope you can see my terminal now on the screen. I know there's a slight delay on the stream.
It's taking a while to come up. So if you want to just go ahead, Peter. But maybe anyway, I was just about to ask a couple of questions there that might be useful for people. So one is, you mentioned that the Docker container the Docker image contains a number of things. I think one of the first things you said was a Jupyter Lab server.
Mm-hmm.
So maybe we can start with that. What's a Jupyter Lab server?
Excellent question. So if you're not familiar with Jupyter Labs or Jupyter Notebooks, they're really an excellent way of building interactive presentations and kind of data science investigations in a kind of very easily usable format. So they come out of the kind of Python world. In this example, we're going to be using JavaScript, purely because JavaScript's my favorite language at the moment, but we like Python as well. And they're just a really useful and easy way of kind of capturing ideas and code and being able to interact with data and code in a useful way. Is that a reasonable description, Owen, do you think, or you'd probably do better than me on that, would you?
Oh no, that sounds good. I mean, it's we're going to see it in a minute, I guess. Anyway, you're going to share your screen when we start executing code in the Jupyter Notebook, and people are going to see what it looks like and how it kind of helps to. I suppose it's a great way of it has a great place in teaching and sharing content in general, like sharing code, because you can share documentation and the code and run it together in the one browser window.
No, very, very useful.
So it means you don't have to be switching between documentation and a terminal or an IDE.
Absolutely, and I think the other pro tip, which you've been using recently, is the use of Voila with notebooks.
Yeah, that's an interesting one too. You can serve them up as websites. With Voila too, yeah, so that's pretty good, especially for data visualizations in data science, that kind of stuff.
Yeah, so
that's where Jupyter really shines.
100%, and Voila is just a really nice way of turning your notebooks into UIs for, I suppose, non-technical people to use. So it's a very powerful tool. Okay, so apologies for slight disruption there. Hopefully you can all see my console window okay, and the code is readable. So what I'm going to do then is I am going to actually start my container. So to do that, you need to cd into the container directory and run the script run.sh in a bash shell. If you're on Windows, there's also a batch script to start the container. Everything else, of course, should be fine from there if you're using Windows, because you'll be running in a Linux environment within the container. So whilst that's just starting up, I might just make a note on how we configure the container. So you'll find in the workshop in the container directory a file called run.env.template, and in there, this is an environment file. You'll find a number of settings. So the AWS access key ID, secret access key, the default region, and AWS region. Both of those have to be specified. That's just a slight foible between the AWS command line interface and the Node SDK. One uses one environment variable and one uses the other. You'll also need your AWS account ID. You can leave the crawler queue and the analysis queue settings the same, but you'll need to set a bucket name. And if you're familiar with AWS, you'll know that bucket names have to be globally unique. So we suggest that you pick a unique bucket name. So what I've done, if I switch back to here, is that, and there's instructions in the README for all of this as well. Use something like your last name, your company name, and today's date. That way you'll be more likely to get a unique key for your bucket. So if you've put all of those settings in and start your container, you should see something like that coming out in your container output. So that's telling me that my bucket name is available and I'm good to go. And it's also started up the Jupyter Notebook server. But of course, it's decided not to display the output correctly. So I just need to grab that. So
you're just trying to display the output in the log for that Docker container.
That's right, yeah.
So you can grab the Jupyter URL.
That's
right. Yeah. So other people might have to do that as well.
Normally it works fine, but of course, as soon as we start the Twitch stream, I decided not to. So the reason for that is that you need, when Jupyter starts up, what happens is it generates a unique token. And you can only access with the URL with that token in place. And that's a security measure to stop people from running notebook servers and anyone being able to access.
Mm-hmm.
Okay, so let's paste that. If we then paste that URL into a browser, we'll see our notebook load, or our Jupyter Labs load. Great, there we go. And that you'll see all of the different steps for the workshop in there. And if you click on the navigation on the right, you'll see in step 2, there's a notebook called step2.ipynb. And this has a little bit of text in it. And it also has some code in there. So what we're going to do now is go back to the instructions. So once you've got your container running correctly, we're just going to double check everything. And we're going to double check that by just listing buckets using the AWS CLI. So if I go back to my container window here, which is running here, I'm going to do AWS S3 ls S3 : / and that's going to list any of the available buckets that I have in my account that I'm connected to. If you haven't got any buckets, you'll just get back no response. But if it's configured incorrectly, you'll get an error message back. Then what we're going to do is just to confirm everything's okay by running this script in our notebook. So this is going to do exactly the same thing, but using the AWS SDK. So here we're saying require the JavaScript AWS SDK, create an S3 object, and then use that object to call the list buckets operation, and then print out the data that we get back, and we should see no error. So you can run the code by pressing the run button at the top of the notebook. And in a moment, there we go. So we get back no error and the 2 buckets that we already saw listed in the command line. So we are good to go now, thankfully. If you do start the container and you see an error message similar to this, typically what it means is that your bucket name is already taken, in which case we've provided a little script called check bucket. What that will do is if you run check bucket in the container with a new random bucket name that you want to use, that'll tell you whether the bucket name is available. Once it's available, or once you find one that's available, you'll need to reconfigure the environment file. So you should reconfigure the environment file, then kill the container, and then restart the container by running run.shut again. Everything should then start up correctly once you have the right unique bucket name. Okay, so if we've got everything set up, let's move on to step 3 and take a look at the serverless framework. So I suppose the first thing to mention about doing deployments on AWS or indeed any cloud, but of course here we're focused on AWS, is that there's an enormous range of tooling, and that tooling is growing in scope and capability almost on a month-by-month basis. And all of these tools come under the heading of kind of infrastructure as code or tooling to help with infrastructure as code. So those would include things like SAM, AWS SAM, Amplify, HashiCorp's Terraform, or the AWS Cloud Development Kit. For Ethereum, we've used pretty much all of them and in various different mixes. And they're all pretty capable tools. Generally, under the hood, they use CloudFormation, except for, of course, Terraform being the odd one out there. And of course, you can use raw CloudFormation using YAML or JSON if you wish. They just tend to get a little bit verbose, which is why we would recommend using something like CDK or Serverless Framework, of course. Oh, and you've probably got some comments on that, I think.
Yeah. When it comes to developing this kind of application, particularly the kind of stuff we're talking about, which is getting results quickly, getting from AI systems quickly, I suppose you want the tooling to get out of the way and do a lot of the heavy lifting for you. I think because we're using a lot of Lambda functions and we're wiring those into different event sources that trigger those Lambda functions, the serverless framework is ideal for that. And the AWS SAM would be an alternative that also provides those kind of higher level abstractions so that you don't have to configure every single resource required to get Lambda functions up and running. They give you the option to create really concise syntax and get it deployed pretty quickly. So I think for this kind of example, serverless framework is probably the best choice. The serverless framework, one of the areas where it really shines as well is that it's got a pretty big plugin ecosystem of plugins from the community. So no matter what your edge case is, if you need to work around specific AWS CloudFormation issues, that happens from time to time. Serverless framework has you pretty well covered.
Yeah, that's true. It's a pretty good ecosystem. So let's have a quick look at what serverless does under the hood to accomplish its magic. So I've got a little diagram here that kind of depicts that. So what we're going to do in a moment is look at some serverless configuration and run a deployment. And what's going to happen then is the framework is going to take this YAML configuration and compile it into a CloudFormation template. It's going to push that template then up to CloudFormation and then allow CloudFormation to do the heavy lifting of deployment of artifacts and so on in AWS. What it's also going to do in the case where we have defined Lambda functions within the serverless YAML, it's going to take that code, bundle up all of the dependencies, push those into a deployment bucket from where CloudFormation can fetch the bundled zip deployment and deploy it into the actual Lambda function once it's created the container to hold the code. And of course, it's not just Lambda functions you can deploy. Any AWS infrastructure can be deployed through the serverless framework. It's really a question of whether you should use the serverless framework in a particular context or whether another tool is more appropriate. Typically, I think I would err on using something like CDK for underlying infrastructure, so VPC configuration, that kind of stuff, and then serverless framework for things that look like microservices, so where you're bundling code and functions that actually own a particular resource. Owen, you'd be a similar mind there, I think, or do you want to add any caveats to that?
Yeah, I think so. Pretty much CDK shines where you've got anything dynamic. So if you have variations between environments, or if you have code that needs infrastructure that needs to be dynamically generated based on any given number of inputs.
Yeah.
So that's where CDK is really good. You use it quite a lot for deployment pipelines, where you might be automatically generating a pipeline for each service, and the number of services is going to rise and fall. CDK is really good. But yeah, anything with a Lambda function, I tend to use serverless framework or SAM because it just reduces the amount of syntax there. Now you can use SAM with CDK as well. So there's you can mix and match these things too.
Yeah.
But I think serverless framework and SAM, they're similar in what they do. SAM is a little bit more rigid. I suppose being an AWS as opposed to an open source community project, it's very it's strict in its use of CloudFormation and in its respect of the CloudFormation rules. The serverless framework tries to get around the rules a lot more.
Sure. Yeah. No. I think
so it's more flexible, but as a result, you sometimes end up on a kind of dark, unsupported path.
Yeah. No. I think that's a fair comment. So what we have here is just a very simple serverless configuration file. So it has a provider section, in this case AWS, of course, a named runtime, a stage, and then a region to deploy to. And in this case, it's just a simple handler function, hello, and that's triggered by a HTTP event. And if we were to write this, the code for this function, it would look a bit like this. It's just going to respond with the string hello in a JSON message body. So that small amount of code will actually trigger the deployment of both a Lambda function and an API gateway into AWS. So really, the serverless framework you can think of as a kind of domain-specific language, which makes a bunch of configuration assumptions for when you're deploying your code. Okay, so let's move on. Now we've had a look at how serverless works, or the serverless framework works, sorry. And let's go ahead and deploy some infrastructure. So let me go back to my code window here. So in the repository that you cloned, you should find a directory called system. And under there is all of the code for our system that we're going to be deploying. So if we look in the resources directory there, you should see a file called serverless.yaml. And this is the serverless configuration for our underlying resources that we're going to build the application on top of. So let's go through this in a little more detail. So at the top we have a custom section, and in there what we're doing is importing some environment variables. So these environment variables were defined in the container environment. So we went through that a little while ago. You create an environment file, you set your bucket name, my crawler queue and my analysis queue are already set, and you have a default region and your AWS account ID that you would have configured in there. Okay, so then we have a provider section, so naming AWS and the node 12.x runtime, and we're setting the region there. Notice that the configuration here is this syntax means use this environment variable as a default region, but if that environment variable isn't set, then default to EU West 1 if that environment variable is missing. Okay, then we have.
Can you increase your text size a little bit in the terminal there, Peter? Zoom in a couple of
yeah. Is that better?
I'll tell you when it comes back through.
You'll tell me when the stream delay hits. No problem. I've gone up a couple of points there, so it should be fine. Okay, so then we have a resources section, and in the resources section, in this configuration, we're defining a bucket. So this is our bucket definition here. We're defining a bucket policy, and then we're also defining two SQS queues. So one is the crawler queue, and one is the analysis queue. In this context, what we're doing is defining a bucket with public read, because we're going to publish our API and our front end out of it. Owen, you want to make a comment on public buckets?
Don't use public buckets. For cases like this, when you want to demo, you want to serve some HTML or a web page quickly, and that's the only thing in your bucket, and you're just giving read access publicly. That's fine, and just get rid of it afterwards. But in general, public buckets are something you should be watching out for and alarming on in your system, because it can happen accidentally, and there have been many public examples of data breaches because of buckets being left open. So you should be scanning for that kind of thing.
100%, yeah. But in this context, it's fine because it's only read access that we're giving, and also we'll be tearing the system down after we've put it in place. So just to caveat that, and make sure generally you don't use public buckets. Okay, so what I'm going to do then is switch back into the container. Let's clear that cruft away from there. I'm going to cd into the system directory, into work/system. And in there, you'll see all of the code for our system there. So home dev work system, cd into resources. And you'll see we have the serverless configuration file that we had before. So what I'm going to do now is just deploy those resources. So I'm going to run serverless deploy, and that's going to run the compilation process that we spoke about earlier, compiling some CloudFormation template, pushing that up, creating a stack, and then deploying all of the resources associated with that stack. So that's going to run away there in the background for a moment, and when that finishes running, we'll take a look at what it's actually gone and deployed in AWS.
Yeah, and it's worthwhile having a look at what it is deploying, because when you have a Lambda function like that with a HTTP event, we kind of skipped over it when we were going through that declaration. But that's going to create quite a few resources to get an API gateway, REST API up and running like that. It needs to create.
Well, in this case, we're only deploying resources.
4 resources.
Yeah, there's only resources in here, so maybe just to call that out. So what we're doing in this step, if we look at the code again, is there's no Lambda functions being deployed. We're merely deploying underlying resources in this step.
Okay. Yeah. Good point.
But you're right in general. So if I go to CloudFormation whilst that's deploying, we might just see what's going on as it deploys. So you'll see I've got a new stack created in this account called resources dev, and that's showing that it's got an update in progress. So if I click on that, I might even be able to see the events as they play through. It's finished. Okay, so that's finished updating. So if we come back to our container now, we should see that indeed that has completed. So let's go and quickly check in AWS that everything that was in there was created correctly. So first of all, let's take a look at S3. And if I do that, we shall see shortly that there's my bucket that's just been created. And if I go to, what you'll also note as well is that there's another bucket being created there. And this is an artifact of the serverless framework. Every time you deploy something into serverless, it'll actually create a bucket and then use that bucket to communicate all of the changes and templates that it needs to CloudFormation. Owen, do you want to give the pro tip on how to improve that workflow?
I'm missing the point, Peter. Improving which part of the workflow?
Oh, sorry. So the annoying piece where if you don't configure serverless framework correctly, you'll get a plethora of buckets being created for each deployment.
Yeah, I mean, but one of the good things about serverless framework is that it kind of manages that for you, the creation of the bucket it needs to deploy, your zipped up Lambda functions and CloudFormation templates. If you're doing that for many services, you'll end up with a bucket per service if they each have their own service YAML. So one of the things you can do is add a deployment bucket configuration, and then just use one bucket that you pre-create and manage yourself for all those deployment artifacts.
Yeah, it certainly keeps things a bit tidier anyway. Okay, so we've got our 2 SQS queues deployed as well, and if you go to the console, if you're working along or if you work along later, you should see them deployed there. Great. Okay, so that's some underlying resources deployed. So let's move on to the next step, which is recognition. So in this step, what we're going to do is take a quick look at some of the capabilities of AWS recognition. And that's the system that we're built. That's the kind of underlying AI-enabled API that we're building this system on. So we're not going to go to the container for this step. We're going to go and have a look at the notebooks. And I'm going to go into step 5, recognition. And okay, so We've got just a note that there's a little file called support.js that has some additional supporting code that's loaded into this notebook. I suppose the other thing to note is that we're using something called iJavaScript, which is a notebook plugin, and that allows you to run JavaScript in your notebooks. By default, the default engine is, of course, Python in Jupyter Notebooks. So we've got some test images, and these are all in the repository. So once you have your container up and running, you can just run this code. And what that will do is it will push those images up into the bucket that you've just created. And you'll note that we're using the URL s3 $mybucket name. So again, what's happening there is that Jupyter is importing that environment variable, mybucket name, from the environment, and because it's running in the container, everything works out. Okay, so let's just run this to push some images up and give that a moment. Okay, there we go. So let's push those images up. You'll notice what we're doing here is actually cheating. We're running an exec to run the AWS CLI rather than looping around and doing put objects or whatever. Okay, so the first thing that we pushed up was an image of a cat. This is a cat detector system after all. And what we're going to do is run label detection on this. So label detection means, given an image, give me a set of labels that you think pertain to this image, and also tell me what your confidence level is in those labels. So to do that, it's really quite straightforward if you're familiar with calling APIs. We set up some parameters, and in this case, we set up an S3 bucket and an image inside that bucket. We then ask for a maximum number of labels. In this case, we only want 10 labels, and we only want labels where the confidence level is greater than 80%. So if the confidence in the detection is less than 80%, don't bother returning the label. From there, it's a simple case of calling recognition detect labels and then printing the results out. So I'm going to feed this image into detect labels now. And in a moment, we should see some response. Okay, so this is the raw JSON response coming back from that. So for that image, we've got an array containing a bunch of JSON objects, and each one of those is a label, so the label name, and a confidence level. So you'll see that we've detected cat, pet, mammal, animal, Abyssinian, and Manx, which are types of cat, I believe. I'm not much of a cat fancier myself. And I've just got a little formatted version of them there. So the system that we're building today is based largely on this API. So I think we can all agree that's an awful lot of power for a single API. Okay, so what are the other capabilities you can do in recognition? Well, here's a bunch of smiling happy executives at a business meeting. I do remember business meetings. It's a while ago now. And what we're going to do is we're going to call the recognition API detect faces on that picture. So again, it's a simple process of sending in the bucket name and the image name and then asking for face detection. When we run that, which I'll do now, we're going to get back a bounding box and a confidence level. And some other bits and pieces that we're not going to be concerned with here. So as you'll notice here, the confidence level is very high in each case for the face detection. So if we were to look at what was in the rectangle, in the bounding box, you'll see that we get two pairs of XY coordinates. If we take those XY coordinates and then draw a box using those coordinates, you'll see that the detection is indeed fairly accurate for that image. In fact, I would say very accurate for that image. So again, a lot of power from a single API call. Now, here's a bunch of actors at a recent awards ceremony. I'm not much on celebrity, so I was a bit surprised to find that Recognition has a Recognize Celebrities API off the shelf. And then I thought about it a bit, and I guess for news organizations who need to be able to identify people of note in images, then maybe it's a useful thing. So let's run that now and see what we get back. Okay, so again we get some rectangles, and I haven't actually displayed the raw JSON here, but we get some rectangles, and with that rectangle we have a confidence level, and then we also have a name. So you'll see here that we've detected Daniel Day-Lewis, Tilda Swinton, and I don't even know who that is. So I'm not much of a celeb fancier, Owen, I'm afraid. Sorry.
That's Javier Bardem, Peter.
Okay.
So we don't.
Some famous chap, anyway. There you go. All right, very good, excellent. There you go. I'm just not down with the kids, right? So again, a lot of power in a single API. So the final example of recognition now is finding faces in images. So on the left here, we've got Jean-Luc Picard on the bridge of the Enterprise doing his famous meme pose. And on the right-hand side, we have Patrick Stewart at an Oscars ceremony. And we're going to use this image. We're going to feed this to recognition, and it's going to find the primary face in this image. And then using the primary face in that image, it's going to try and find the same person or the same face in this image. So what we're doing really is almost like string comparison or string search, but with faces. And again, the calling sequence is quite straightforward. We supply a source image, which is the picture of Picard, and then we supply the target image, which is the Oscars picture, and then we ask recognition to compare faces. And if I run that now, we should see in a moment that we get similarly the bounding boxes back. And if we take those and draw them on the picture, which my notebook is taking its time to do. There we go. You'll see that we've detected Patrick Stewart in that picture. So again, confidence levels and everything coming back with that. So that just covers off some of the capabilities of recognition, which I think are very interesting, particularly if you think how you can apply them in your own work. I certainly think there's an awful lot of power in there to be exploited. Okay. So let me move back to the workshop, and we'll move on to step 6. So now what we're going to do is deploy the crawler service. So rather than going through the README, what I'll do is switch over to my code window, and we'll take a look at the crawler service. Okay, so the crawler, the job of the crawler is to listen for messages, let me rephrase that. The crawler service gets triggered from messages on an SQS queue. When it receives a message, the message will contain a URL. The crawler will pick up that URL, fetch the resultant HTTP at that URL, bring that down, look for image tags and various other image clues within that HTML, and then it will go off and fetch each of the images and put them into an S3 bucket. So let's have a quick look at the serverless for that. So this should hopefully start to look a bit familiar. We have the custom section at the top where we're importing environment variables. The provider kind of boilerplate, just targeting cloud and runtime. And then we have a bunch of role statements here. So what we're doing here is allowing the crawler permissions to put object into our bucket, to list SQS queues, to receive messages, and also to send messages on the SQS queue. It doesn't need any more permissions than that, so we don't give it any more permissions. And now what we're doing is also deploying a function. So that function is crawl images, and it's defined in the file handler.crawlimages. So this first part here defines a file, and the second part defines the function name within that file. We're supplying an environment variable block. So here we're allowing it access to the bucket name, the analysis queue, the region, and the account ID. And then in the event section, what we're setting up here is the SQS trigger to call the function. And if we look at the handler code, so that's in handler.js, at the bottom, you'll see we export from this module a crawl images function. And that has a standard handler signature of event, context, and callback. And in there, essentially what it does, I'm using the async module because I'm slightly old school at the moment. I could probably upgrade my ways. I know Owen is probably going to chastise me for that. And essentially what we do is just parse the body of the message. And from that, we look at the action. If the action is download, which is what we're expecting, what we then do is look at the URL, and then we call the crawl function. And the crawl function basically just uses, there's a file called images.js, and there's some kind of reasonable code. And what that does is to fetch and download and decode images. So I won't go into the details of that. You're more than welcome to take a look at that offline, and I'd be delighted if anyone wants to send me any pull requests if they think that code can be cleaned up at all.
So essentially, Peter, just to break this down, because there's quite a lot on that crawler service. It takes in messages on an SQS queue. So what do those messages contain? What's the instruction in each message?
Yeah, good question. So let me jump forward slightly. Let's go to, because once we've deployed this, we're going to test it in a moment. So if I go into the step 6 notebook, you'll see a piece of code in there just further down, which actually tests this function by sending in a message. So you'll see here the message. So it's a very simple piece of JSON that has an action attribute and then a message block. So action is download, and then the message just has a URL in it. It's that simple. So all it does is pick off that URL and then go fetch images from it.
Okay, great. So it's going to fetch images, and the point of that is that it's going to fetch them and put them into a bucket so we can start making recognition requests.
That's exactly right, yeah. In fact, what it does is it puts them into a bucket, and as it puts them into a bucket, it also posts a message into the analysis queue to asynchronously trigger the analysis service.
Okay. So how does it, if you give it a URL, how does it actually take the images in that URL and put them in the bucket? What's the magic there?
Yeah, no, good question. So once it's got the images, it needs to use. Actually, if I come to the top of this code here, you'll see that here we import the AWS SDK. Then we create an S3 object so we can interface with S3, and then we create an SQS object for interfacing with SQS. So if we chase down a little bit further, you're seeing we're doing a S3.put object. That's actually writing the status file, which we'll have a look at in a moment. And then in images, I believe we're doing a put object here as well. So there's a function called fetch images. That uses, sorry, I'm skipping around slightly. That uses the request module to pull an image down. Once it has that data in a buffer, it uses the S3 put object API to actually write that into a bucket. So it constructs a key, it constructs a unique key for that file that's just downloaded, and then basically streams that buffer from memory straight into S3.
Okay, great.
Super. Okay. Right. So let's flip into deployment mode. So you'll notice we also have a file called package.json in here. So I'll come to that in a moment. Let's kick the deployment off actually first. So first we will need to do an npm install. And I'll talk about that in just one moment if you're not familiar with Node. So npm is the kind of default Node package manager, and what that's just done is it installed any dependencies that are required by our module. So I'm just going to do a serverless deploy, and whilst that runs, let's have a quick look at package.json. So this is our package.json for the crawler service, and you'll see in here a few modules that it depends on. One is the request module, one is a HTML parser, and of course then the AWS SDK for interfacing with the various downstream services that it needs to deal with. Before you deploy any serverless function, if you've got code there, you obviously need to make sure that all the dependencies and packages that are required have been downloaded through the package manager. Those will then be bundled up with the code when the service framework makes the deployment happen. And that's just running in the background right now.
Yeah, that's something that can be problematic after a while, given the size limit for Lambda functions. Isn't that right, Peter? And the propensity with Node.js modules to be often bloated and to bring a massive tree of subdependencies with them.
Yeah, I'm a little bit ambivalent about that, because I do think that the way Node solves the kind of package dependency thing is pretty good. In the sense that, if you've worked with other systems like Maven or even the Go package manager, they tend to adopt this kind of centralized on one system approach. And the aim there is, I suppose, to try and save on storage. Whereas, the storage is cheap. So I do like the approach of using a kind of node modules per project. But like you say, the kind of downside to that is that you do tend to bring in a whole trees of dependencies, and it can bloat quite quickly, which is unfortunate.
And it has a couple of impacts, right? Because you've got a 250 meg size limit for your Lambda function and all its layers, but the bigger it is, the longer it's going to take to deploy, and it's going to have an impact on your cold start time for the function too, because the code has to be pulled down before it can start the function.
Right.
So ideally you'd like to you'd strive for zero dependencies. But what it does mean is that if you've got a lot of modules, or even if you don't have a lot of modules and you just want to squeeze as much performance out of it as possible, you might want to look at something like introducing Webpack into your backend, so you can tree shake all of those JavaScript dependencies and keep the bundle size as small as possible.
Yeah, no, absolutely. I suppose in kind of development, it doesn't really matter that much. But as we all know, once you start getting to production, these things tend to add up, and so efficiencies in deployment, in cold start times, can make a big difference, as you say, Owen. Okay.
Yeah, I've actually, just to labour the point a little bit more, in Python projects, I've come across these limits more than I have with JavaScript Lambda functions. And the reason for that is that some of the typical data science packages you use in the Python world, like pandas, numpy, and scipy, when you add those three things together, you're already getting pretty close to the limit. And it's pruning those dependencies down is not as simple as it is in the JavaScript world.
Yeah, that's for sure. I have to say I am quite fond of Python, and there's an awful lot of power in those libraries, right? But it does come at a cost.
For sure.
Yeah. Okay, so we've deployed the crawler. So what I'm going to do is just have a quick look at the bucket contents. So this is the Step 6 notebook. We'll kick that off now. And in a moment, we should get a response back. And I think I'm going to have to give a pro tip on notebooks here in a moment, as this code isn't running. So let's just leave that for another second. Okay, so sometimes I have had the kernel stall on the notebook. If that happens, just restart, clear all outputs, and you should be good in a moment. Okay, let's try running that code again. There we go. So now what it's actually showing, of course, is that previously the bucket was empty. We deployed the bucket, and then in step 5, of course, we pushed some images up. So these are just the images that we use to run the recognition demos in step 5. So what I'm going to do now is use this code here to post a message to the crawler's SQS queue. So to do that, we're going to construct the queue's URL. We're going to construct a message which will contain the queue's URL, and then we're going to use the SQS send message API to post that up to our queue. Now, of course, this only works because this notebook is running in the context of a container which is configured with an API access and secret key. You of course couldn't call that just from anywhere, just to make that point. So let's run that, and we get a message ID. So what's happened is that should have been picked up by the crawler, and it would have gone off and picked up some of those images. In fact, we've got a little test page here, and if you look at that, you'll see there's just some dog and cat pictures, which are very cute, and that's what's been downloaded by the crawler. So if I go back to my notebook and just rerun the code up here, we should see, and indeed we do, that there's a bunch more images in there, and those are the images that the crawler has just downloaded. It's also created a status.json file. So to check the results, what we're going to do is we're going to need to change this string here slightly, because the crawler has created a unique code for that download. And so if I just update that here. So again, what we're going to do is we're going to look at the contents of the status.json file. So this was created by the crawler on download. So we're just going to use the S3 API to get object and then display the contents of that status file. So if I run that now, you'll see that it's basically got a list of each of the images that it's downloaded with a status, and that's it. But that looks like a good download. Okay, so step 6 looks like to be working well. We have a working crawler function triggered through an SQS queue. So let's take a look then at the next step, and that is step 7, of course. So step 7 is deployment of the analysis service. So let's go back to our code in the command shell here, in the container shell, and under the system analysis service directory is where we're going to find the code for this. So whilst I'm explaining this, what I might just do to make things more efficient is to cd into analysis service and run an npm install in the background. Just let that run away. Okay, so let's have a quick look at the serverless YAML file. And in here, you'll see what's hopefully become a fairly familiar pattern over the last few pieces of code that we've looked at. So we have our custom section, importing environment variables, provider block, some role statements that give permissions to this Lambda function. And we also then have our Lambda function definition. And in this case, it's handler analyze images is the entry point. We provide that with some environment variables. And again, this Lambda function is triggered through an SQS queue, but this is a different queue. This is the analysis queue that we deployed back in step 4. So we've installed our dependencies. So I'm going to do a serverless deploy. Incidentally, using SLS is just an alias for serverless. We'll kick that off in the background. And whilst that's running, we'll have a quick look at the handler code. So hopefully, again, this handler code should look fairly familiar now at this point. We're importing the AWS SDK. We're creating an S3 object, and we're also creating an AWS recognition object. Down at the bottom of the file here, you'll find analyze images. So this is the entry point, and that has the standard entry point signature of event context and callback. And essentially what we're doing is unpacking the message in the same way as we were for the crawler service. This time the body action is analyze, and within that we'll have a reference to the image to analyze. So given that message, we call iterate bucket, and what that does is it calls list objects v2. So that basically filters the bucket to give us a list of objects, and for each object it is going to run an analysis by calling AWS recognition. And it does that further up here. Sorry, I've lost. Sorry, my screen is updating a little slowly there. So I just need to get to the function. There it is. Okay, so it calls this function analyze image labels. So this code should look familiar because what that's doing, and I seem to have lost my syntax. Okay, analyze image labels, and what that does is this should look fairly familiar because we already called this code in the notebook previously. So it's called in recognition detect labels, and we're feeding it max labels 10, min confidence 80. So for each image, we're essentially feeding that into recognition and then getting a result back. And for each response we get back, we're writing a response into our status.json file. You'll also notice if you look at this code a little more closely that we have a file called word cloud list. What that's doing is building a set of a JSON object that has a number of words and the frequency density of those words. And when we feed that downstream later on, that'll allow us to build and render a word cloud in the front end. And that's a fairly simple piece of code as well, because all it's doing is looking at the labels returned by recognition to build that simple object up. Okay, so we finished the deployment of the analysis service. So let's go check out that it's working okay. And we'll do that by going back to our notebook. And if I go up to step 7 analysis and we look at step 7 IPY&B, we'll check the bucket contents again just to make sure the notebook is running. And it is, so that's all good. So this time we're going to post a message to the analysis queue rather than to the crawler. No, I'm sorry. I stand corrected. We're going to post a message to the crawler queue. That's going to trigger the crawler to just re-download that site. The crawler is then going to trigger the analysis service and stream all the way through the pipeline. And at the end of this, we should see some results from recognition written into our status object. So let me just kick this code off. And you'll see there's a message ID at the bottom there, which means that that was successful. And if I kick this bucket again, we should see some additional images being downloaded, which they have. And what I'm going to do now is check the results. So what this code is going to do, just as a reminder, is to download the status.json file that was written out by the analysis service. So if I run that, we should see now that we have our download results. But also now an additional block of analysis results in there with the detected labels for each image, which is fairly verbose. And then we also have our word cloud list. So this is just word frequency and the numbers there. So we have a working analysis service, so that's good news. So we need to then move on to the next step, which is step 8, which is to build a user interface on top of everything we've created so far. Owen, any comments from you on those two services, or anything I missed talking about?
I don't think so. It seems pretty clear to me, Peter. So yeah, I think that's pretty good. Yeah, I can't wait to see what you're going to build next with it, because I know
You've seen it before.
Yeah, we start visualizing some of it.
Yeah, it's much better when you can see it, right? Okay, so what we're going to do is we're going to deploy the UI service. Now, sometimes I think, when you go kind of word blind on things, right? Because really, this is just the API for the system, right? So I think API would have been a better name for it rather than UI. But when you spend so long tinkering with stuff, you kind of go a bit word blind. So we're going to stick with the UI service for now. But essentially, what this is going to do is deploy an API over the services we've just built. Okay, so let's get into the code. So the code is in the UI service folder, and we have a servers.yaml and a package.json. And what I'm going to do is I'm going to So I'm going to cd into the UI service, and I'm going to do an npm install to install dependencies whilst we look at the code. And again, this should be very familiar at this point. So again, importing environment variables, setting up the provider block, defining IAM role statements. Again, I suppose the point here is to use least privilege, so only give the Lambda function permission to execute what it needs and no more. And then we have our Lambda function definitions here. Now you'll notice in this case, in the previous ones, we just had a single entry point. Now what we've done here is define 3 different entry points. So these will be surfaced as 3 different Lambda functions. The first one is analyze URL. The second is list URLs. And the third is list images. So what analyze URL does is you'll notice that in this case, rather than being triggered by an SQS event, it's triggered by a HTTP event. And that HTTP event in this case is looking for a post. So what this API is going to do is to take a post request, and that post request is going to send up a URL. It's then going to construct the message body required by the crawler service, and then it's going to punt that into the SQS queue for the crawler service, and that's it. So really, this is an asynchronous trigger to allow the system to ingest and analyze some data. List URLs is simply going to read information from status.json and return it for visualization. And similarly, list image is going to do a similar thing as well. Okay, so let's just kick the deployment off and we'll look at the code. So we'll do an SLS deploy on the UI service and take a quick peek at the code. So this, again, I would imagine should be quite familiar now. We're importing AWS SDK. We're creating an S3 and an SQS object for use further down in the code. Our list images API is really just responding with an image list. I suppose the point actually that I missed talking about there, Owen, is that, and perhaps we should get back to the serverless YAML file, is that this, because we're using a HTTP trigger here, this is going to trigger the serverless framework to create an API gateway for us to connect up those events, right? Do you want to maybe just talk to that for a second?
Yeah, you're right. So when you, with those few lines, when you're just saying events HTTP, you need to create quite a few resources. So you need to create a HTTP REST API, and then a resource, and then a HTTP method. So API gateway is something, you know, where you need to create a lot of resources like that. But generally, it's pretty much boilerplate. So you'll see people as well creating Lambda functions or Lambda-based systems with Terraform, and you end up with quite a lot of HCL code because you have to create so many individual resources. Serverless framework saves you all of that. If you want to see what it looks like, the CloudFormation template you're generating, when you deploy it, there's a .serverless folder in the same folder as the service, and that contains a JSON CloudFormation template.
Might be fun to look at that now. What do you think?
It's it makes you appreciate the concise syntax of framework.
It might be fun to have a look at that. What do you think?
Yeah, go for it.
Okay.
Open it up.
Let's just let this one finish deploying, and
Sure.
Oh, actually, sure. I can just I want the.
It's going to be called something like
CloudFormation template. That's it.
Update. Yeah, it's the update. Yeah, it's the update one. So
let's load that. So this is the actual update JSON formatted CloudFormation template. And if I go to the end, we'll see that contains. Lost my line count there, have I? I think I lost my line count when I hold on. I have to come out of Vim and start again. Okay. We were doing the UI service right, and handler.js and cloud.e.serverless CloudFormation update stack.json. Okay. Yeah. I've lost my line count with reformatting. Okay, right.
It looks to me like it was 840 lines.
Did I miss that? Where did I?
That's what I can see.
Oh, there it is. Sorry, yeah, sorry. What's happened is I'm used to looking over in the far right hand corner at my Vim status line, which has all my counts. But because I've done the fonts and everything, I've just missed that. It's in the middle. You're right. 840 lines. Yes, very good. So it's 840 lines compared with. Lost my line count there again. Significantly less lines anyway. Okay, right. Let's go. Right. Okay, we'll do this properly. Right. So in the UI service,
there's a lot of boilerplate you don't need to worry about.
So I'm going to cat serverless.yaml wc-l. Okay, so 70 lines of serverless YAML. We're going to cat.serverless. What was it again? Cloud promotion template update stack.json. Versus 839 lines. There you go. Let's be exact, right? So 70 versus 830 lines. So 839. So fairly hefty difference there. Okay, so we'll just have a quick look at the handler code for the UI service. Fairly straightforward. I guess the key thing before we went back to serverless was to note that this is actually responding with a 200 status OK code. So this is responding back over HTTP, of course, and is being triggered through HTTP. So what you'll note is that the calling sequence of event, context, and CB is the same in this case. However, the way you interpret those parameters is different or slightly different depending on the context in which the function has been called. And of course, how you respond as well is varies depending on the context in which the function is being called. So I have a little function here called respond, and all that's doing is basically setting some HTTP headers, stringifying the JSON body response, and then sending that back down ultimately back down the socket through cloud through API gateway and back to the browser that's making the call. Okay, so I think we deployed the UI service okay. So what I'm going to do is just go to the console now, and because we've been deploying away busily, so we should have a quick look at Lambda. So this was a clean account that I started with, a clean sub account within our organization. And if we look at the functions now, you should see there's a bunch of them deployed. So this is our crawler service dev crawl images. This is our analysis service. And then these three functions here are all pertaining to the UI service. This one is list URLs, analyze URLs, and list images. Now, I suppose one of the things I haven't done in here is apply tagging because it's a development system, although we do have a naming convention. But Owen, do you want to maybe mention tagging in the context of larger production systems? Owen, you're on mute, I think.
Thanks, Peter. I didn't realize that. There's a couple of things tagging can help you with. So one of the big ones is billing. So when you need to be able to slice and dice your costs, if you're looking at AWS billing. Other one is just kind of for searchability and grouping of resources. But it's something that Serverless Framework can also help you with, because you can define the stack tags at the top of your serverless.yaml, and those tags will be propagated to every resource within that framework, within that application. So it's something that's useful, and it's a great benefit of cloud formation as well, that you can deploy a whole stack and ensure that the tags you need, that might be a cost center you might have in there for the tags, you might have the service that it belongs to, you might have the environment that is part of, as well as all sorts of different, business specific tags you want to put in there. So yeah, it's always a good idea to make plenty of use of tags.
Yeah, 100%. So as you saw, those are the Lambda functions we deployed. That last deployment also deployed an API gateway. And if you do the same and have a look at your gateway in the console, you'll see that indeed the API endpoints are deployed. So we have analyze, which is a post, list with it, which is a get, and then list images, which is also a get. I guess again to note that we haven't taken any steps to secure this API because this is a demo system. Obviously, for real API, security is going to be number one concern. So that would mean things like either restricting access by using API keys or securing with something like Cognito or Auth0, or custom Lambda authorizers. Okay, so now that we have that deployed, let's go back to our notebooks. And we're going to go to step 8 UI, and we've got a little notebook here that's going to test our UI. So first of all, we need to make a little edit, and that's because when we deploy our API, you'll notice that the serverless information spits out the routes for us. So in order to make our notebook work, I'm going to need to just copy that hostname or the start of that hostname portion into my notebook to point it to the new API that I've just deployed. So that is quite simply done just by replacing that string there. And when we run this, this is going to list the URLs. So if I kick that off now, we get a response back. So this is saying, oh, sorry, I apologize. It's actually doing a post. Sorry, it's kicking off another ingestion. Apologies, is what it's doing. I read the code wrong there. You'll note now that we're not loading the AWS SDK into here. That's because we've now moved up a level and we're actually calling our API, which is doing all of the AWS work for us. So this is just a traditional standard API execution. So let's check the URL list, which is the one I thought we were executing a minute ago, and just change the host name again. So we're pointing to our new freshly deployed API. And if I run that code, we should get a response back. So we can see that these are the URLs that we've analyzed, and we've got a status of analyzed on each one of those. So remember, we posted a message when we tested the crawler queue. We posted a message when we tested the analysis queue, and we just posted a message through the API, which is why we've got 3 different URLs in there. Okay, so that all appears to be working, which is great news. So let's move on to the final step and deploy the front end onto the system. And I'll just hit forward to step 9 there. Okay, so again, I won't read the README. Let's just go to the code. Okay, so we've got in the system directory, there is a directory called front end service, and that's where all of the code is. Here, of course, you won't notice any serverless.yaml because this is a simple piece of code for a single page application that's going to run in a browser. The key file there is code.js. So in code.js, we've got a bunch of functions that are going to, one, render a histogram, and they're also going to render the word cloud for us. There's also a file called wordcloud2.js, which is an open source word cloud generator, and then just a few simple templates, which are going to be used to render lists. And the HTML for the application is very simple as well. All it does is import some links and scripts, and then just has a div content area where all of the action happens. So we do need to make some edits to this though. So if you look in code.js, there are a couple of definitions there. One is bucket root, and then the other is the API root. So if you recall, we've just replaced our API. We've just deployed a fresh API. So I was testing this earlier, so I have a URL here that I need to change now. So to do that, I need to pick up the API name from there again. And then I'm going to paste that in and then just tidy the string up. That means that when I deploy this code, it's going to be pointing to the new API. I used the same bucket name earlier, so my bucket root is already configured correctly. And in a minute, once we've deployed this, we're going to then browse to this URL. So I'm just going to, I'll copy that now in a moment. So to run the deployment, and these instructions will be in the notebook, we're not going to use the serverless framework. All we're going to do is to sync these files in the application directory up to our bucket. You'll note here that I'm not using any JavaScript frameworks, apart from a little bit of jQuery, which is not a framework. Owen, whilst I deploy this, maybe you want to comment on JavaScript front-end frameworks.
I love them. I think we need more of them, actually, Peter. There aren't enough.
What the world needs is just one more JavaScript framework, right?
I don't do as much front-end development as I used to. There's a huge amount of complexity to it, but as well as a huge amount of power, it's very difficult to know what way it's going. But I suppose there's a lot of claims of bloat, and people get very frustrated with the amount of code people download into single-page applications on the front end. There's a lot of pushback and talking about going back to the original origins of the web and just using HTML and serving it up from the back end. But at the same time, you and I both been through the days of supporting IE6 and IE7, IE8, and the issues of trying to achieve browser support. I think those days are largely behind us. I hope at least. You see some patterns of browser vendors trying to regain some control. But at least IE7 is in.
Yes, well, I unfortunately, it did bring back nightmares there when you mentioned IE6, because I do recall IE6 as well. But that's just kind of showing my age, I guess. Things are certainly better than they were, but I do agree with the certain level of frustration around front-end development. It should be immediate, and it's with transpilation and all this kind of nonsense. It's not, unfortunately. But I do some front-end development, but I must confess, not as much as you have over the last while. So my knowledge wouldn't be as strong in that area as you. Okay, so I'm just going to deploy this now. So we're just going to do a sync using my bucket name, and that's should be a pretty quick deployment. There we go. We're done. And so what I'm going to do now is I'm going to copy this URL. This will now allow me access to the bucket, and we'll load the index.html file that we just deployed. So let's paste that into a browser, and we should see front-end loading. It's not super pretty, but then I'm not a front-end developer, but it does the job. And also, I suppose, in our defense, and I suppose we did challenge ourselves originally when we wrote the first version of this code. We did it in a day. Now, it was quite a long day, but it was to prove a point that you can write a cat detector system in a day, right?
Yeah, for sure. Yeah.
Okay, sure. So what I'm going to do then is paste the URL into the top bar there and click Analyze. So what that's going to do, as we should all probably understand by this point, is to call the Analyze API. That's going to trigger the SQS queue. It's going to feed it into the crawler service. That's going to scrape some images. It's then, oh, hold on a second. I shouldn't have pasted that in, should I? That was the wrong URL. That's what it's going to do. It's going to scrape some images. Once it's scraped those images, it's going to make them available for rendering in the front end. So what I'll do next is find some... Do you know what? I think we might have a problem with our API. I think I might have made the wrong... I might have pasted the wrong code in there. Just one second.
We're live debugging now.
We're live debugging now, so this is on the edge of the seat stuff, right? Let me just double check that. No, it looks like I got it right. Okay, let me just reload that. There we go. I must have fat fingered it. I think I made a typo when I put the name in there. So what we've actually got here, of course, is the three URLs that we've posted already that have been analysed. So if we click on one of these, we should be able to see the word cloud and the lovely kittens and puppies and stuff that are on that page. But let's give it something a little more challenging. So let's go off to Google and let's look for cat pictures. And if I Google cat pictures and I go to images, you know what? When I was writing this system, I never got the COVID cat, but since lockdown, COVID cat starts appearing near the top of the image list. So let's go back and we'll paste this in. So this is the URL from the Google image search for cat pictures. So when we post that in, that is going to call the API gateway, trigger the crawler service over SQS, which is going to subsequently trigger the analysis service. All the results are going to be written into S3. And if I refresh the page now, we should see that, yeah, that's been analyzed. And if I hit that, we're going to see that it's picked up animal pets. It's done pretty well with COVID cat as well, which is good to see. And also a histogram of word density there. So when I often talk about the book, one of the things that I use is giraffe pictures. And the reason for that is that I have some friends who are experts in image recognition systems, of which I am not an expert in image recognition systems. So if we take the giraffe images and paste them into the system, we're going to see how well it gets on with giraffes. Typically, giraffes are confusing, I believe, because they can be mistaken for cheetahs, or they just have very long necks, right? I don't know the exact reason why they would confuse AIs, but that's what I'm told.
You know that giraffes can clean their own ears with their tongue because their tongue is so long, Peter.
I didn't know that.
21 inches. I came across that fact yesterday. I thought it was important to share.
That's important to share. Well, I have two other very interesting facts about giraffes that I'd like to share as well, right? So first of all, did you know that the giraffe is the animal with the highest blood pressure out of all of the mammals, right? Because it has to pump blood all the way up to the head to its brain. And the second thing that's fascinating is I think it's the vestigial nerve in the giraffe, right? Which is a nerve which actually I think runs the brain from somewhere just under the chin. But in actual fact, where that nerve runs, it runs all the way down the giraffe's neck, round the sternum, and then all the way back up to the brain. I think it's called the vestigial nerve, and the reason for that is because as the giraffe was evolving its long neck, each of the small steps was only a small increment, and it was, I presume, evolutionarily not beneficial to change the vestigial nerve on each of those small ones. So you eventually end up with this long. There you go. Fascinating bit of biology there for you. Let's get back to the AI, shall we?
I think the tongue fact was more interesting.
I think in fairness, you beat me there. I think the tongue fact is way more interesting. Okay, so this done pretty well with giraffes, right? Sorry?
It's slightly gross.
Slightly gross, yeah. It's actually done fairly well with giraffes, and I think the reason is, or my theory is, that the people that build recognition, of course, know that giraffes are going or are well known to challenge systems like this, and therefore they've taken extra care to make sure that giraffes are recognised. So the other images I always like to search for are Terminator, just because dystopia, AI, and all of that. And if we try that, we'll find that in a moment it will have analysed those images. And Terminator, there we go. And it's found humans, performers, accessories, clothing, and sunglasses. It hasn't found any killer robots, though. And that looks like a killer robot to me. So I'll leave you to make of that what you will. And we will move on to step 10, which is wrap up. don't bail just yet. Wrap up is very important because what we're going to do is just very quickly delete everything that we've just deployed because obviously we don't want to incur any additional charges for resources that we've deployed. So in order to do that, first of all, we need to empty the bucket. So I'm going to use this command, or you can obviously do that through the AWS console as well. Sorry, I keep swiping force a habit. Okay, so in my container then, AWS S3 RM S3 my bucket name minus recursive. That's going to clear everything in the bucket that we've just created. So all the images that have been downloaded. Obviously, be careful when you're running that command. Make sure you're pointing at the right bucket. Okay, and then next we've actually provided a script called remove.sh at the root of the system folder. So I'm just going to step in and run that. So there is remove.sh. Let's just have a look at that. So all that does is basically iterate around each of the services that we've just deployed and calls serverless remove. So you could manually go and do it. That's just a bit of a pain. So we're just going to automate that process. So I'm going to do bash. And that will remove everything that we've deployed and clean our account back to where it was before we started. So we're not going to incur any additional charges. And that is the cat detector workshop. I hope that was useful and informative. All of our contact details are available on the repository. We'd be delighted to take any questions on Twitter or LinkedIn or email, and also delighted to receive any pull requests if you have suggestions for improvement on the workshop. We also have some other open source, particularly Owen has a Slick starter kit. Maybe Owen, do you want to just mention that briefly whilst we're undeploying?
Yeah, so one of the things that we've found is that setting up these serverless projects, especially when you've got any reasonable level of complexity in your system and you're trying to cover out all the non-functional cases like you need to when you're getting to production, like continuous deployment, testing, monitoring, observability. There's quite a lot to consider actually, especially in a highly decoupled distributed system as serverless deployments tend to be. So having put many serverless systems into production, we decided to kind of take all our learnings and our standard practices. And we created a template project that we use ourselves, and we also decided to open source it. The project is called Slick Starter, SLIC. If you Google Slick Starter, you'll come across it, and give it a go on GitHub. I mean, it's a pretty comprehensive project, so it's not just a basic tutorial. There's quite a lot of code to it, but because of that, a lot of our customers and other people we know have used it to bootstrap their serverless applications. So people have built, working SaaS applications on top of it. So it's it's something that we're continually trying to evolve. So if you find it useful, then give us some feedback and definitely submit pull requests. We're well up for that.
100%, yeah. So the URL there is github.com/fortheorem/slick-starter, or if you go to slick.app, you can also reach it from there. And as Owen says, we'll be delighted to have any pull requests or improvements or suggestions on that. Okay, super. So I think we're nearly finished undeploying there. So we're just removing the analysis service, which will be the last one. And then we will be done. Any questions that we need to address, Owen, or are we all good?
We're all good on this end, Peter. Yeah. So anybody can reach out to us. Like you said on Twitter, and we'll be sure to get back to you.
Super. Okay. Well, listen. Thanks everybody for attention. Hope you enjoyed it. Hope it was useful. And we'll sign out now and look forward to hopefully interacting with some of you later. Cheers. Bye bye.